FM capture effect is the complete suppression of the weaker signal when two signals on same frequency are simultaneously received by an FM receiver. This typically occurs at the FM receiver's limiter circuit. This is in sharp contrast to what happens in an AM receiver, in which audio from both signals get mixed up. How strong the capture effect is may depend on the receiver's circuitry. How well the receiver rejects a second weaker signal on the same frequency is known as its capture ratio. Capture ratio is measured as the lowest ratio of the power of the two signals that will result in suppression of weaker signal. In case of FM, the stronger signal needs to be only twice as powerful as the weaker signal, while in case of AM, the stronger signal will have to be 20 times stronger to avoid objectionable interference. Even though it was mentioned that FM capture effect occurs in case of two signals on the same frequency, unlike in AM, there is no constant carrier frequency in case of FM. The frequency deviates according to the modulating signal, which is the characteristic of frequency modulation or FM. In AM or amplitude modulation, it is the amplitude of the carrier which changes with the level of modulation. Of course, there will be sidebands on either side in amplitude modulation. Instead of carrier, in FM, we think of center frequency with deviation to either side according to the modulating signal. Now, what is a limiter in an FM receiver circuit? Limiter is a circuit which is used before the demodulator to limit too much variations in amplitude of the received signal, which might interfere with the FM detection circuitry. Thus, the limiter circuit flattens the peaks of FM signal before delivery to the demodulator. Limiter typically sees the weaker signal as an interfering signal compared to the stronger signal. Weaker signal produces fluctuations in the amplitude of the stronger signal received simultaneously. This fluctuation is removed as the peaks of the received signal are clipped by the limiter circuit. This clipping of the amplitude does not affect FM detection, as it looks only at frequency deviation and not at the amplitude of the signal